I'm just going to go through the first differentiation homework. So we start with this graph here, y is f of x, and we have to sketch y is f dashed x, so that's the gradient function. So the easiest thing to do is to plot where the gradient is 0, so that's at this top point, the gradient's flat, and at this minimum point as well. So I'll plot that the gradient is 0 at those two places. Okay, now before that maximum we've got a positive gradient. Okay, it's gradually getting a little bit less steep. So we're going to start from up here and we're getting less steep towards 0. Okay, in between the maximum and the minimum we're going downhill, so that's a negative gradient. It starts off quite a shallow negative gradient, so small negative values, then it goes pretty steep, so big negative values, and then it heads back to 0, so small negative values again. Okay, so if we join up those two bits, there we go. And then finally, after the minimum point, the gradient is positive and it's getting increasingly steep, so it's getting more positive. Okay, so that's our first one. Okay. Question 2, this time we're shown the graph of the gradient function and we're asked for what values of x is f of x decreasing. So we know that f of x is decreasing if the gradient is negative. Okay, so that means we want to look at where the gradient lies below the x-axis. This is where the gradient function is negative, which means the original curve is going downhill there. So we can see that we're interested in these values between 1 and 3. So we have -1 less than x less than 3. We don't put equal to because at those points it's equal to 0, so the gradient's not decreasing, it's actually stationary, it's not changing at that point. Okay. Right, on question 3 we need to do differentiation from first principles to show that the derivative of 3x squared is 6x. Okay, so we're going to use the formula that you get given, which is always good news. Okay, so our f of x plus h, so f of x is going to be 3x squared. Okay, so let me just jot that down. So f of x is 3x squared. So that means that f of x plus h, we're just going to replace the input x with x plus h. Okay, so I'm going to pop that into my formula here. So we've got 3 of x plus h squared minus f of x, so 3 of x squared, all divided by h. Okay, right, and we carry on. So we have to keep writing the limit as h tends to 0, and then we can expand these brackets and we get 3x squared plus 2hx plus h squared minus 3x squared, all divided by h. We continue expanding. Expanding that out, 3x squared plus 6hx plus 3h squared minus 3x squared all over h. Now we can see that 3x squared take away 3x squared means that term will go to 0. So we've got 6hx plus 3h squared. Okay, and then we can divide each term by h. So we're left with 6x plus 3h. And finally, we can take the limit as h tends to 0. So basically we just pretend h is 0 and we are left with 6x, which is what was needed. Okay, let's try x cubed instead. So this time our function f of x is equal to x cubed. So when we want f of x plus h, we are just replacing the x with x plus h. Okay, So if we substitute into the formula we were given, we have finding the limit as h tends to 0 of x plus h all cubed minus x cubed all over h. We have to keep writing, so it's equal to the limit as h tends to 0. We have to keep writing that. Alright, now we expand this out and you get x cubed plus 3h x squared plus 3h squared x plus h cubed minus x cubed, I'll just about fit it on the paper, all over h. Okay, x cubed minus x cubed, so those disappear, so we've got 3h x squared plus 3h squared x plus h cubed, and that's all over h, and then we can divide each term by h. And that leaves us with 3x squared plus 3hx plus h squared. And then finally, we can take the limit as h tends to 0. So this term will tend to 0, and this term will tend to 0, and we're left with 3x squared. Okay. Right. So now we're actually going to use the differentiation rule, alright, to find different derivatives. Okay, let's look at the first one. So we've got, if we're starting with y is x to the 4, then we're just going to apply our rule. So just remembering, we've got if y is x to the n, then dy by dx is nx to the n minus 1. So we bring the power down and we reduce the power by 1. That's the general rule. So for this one, we've got dy by dx is simply going to be 4, bring the 4 down, x cubed. Okay, let's look at the next one. See if I've got a better pen. Okay, this might be easier for you to see. So on B, we are given 9x squared minus 4x plus 7. So this time we just deal with each term separately. So this is 9 times, and this will be 2x to the power of 1. Now we've got minus 4x with like an invisible power 1 there. So we've got minus 4 times 1x to the 0. And then the last term is just a constant, so it's a bit like having 7 times 1, which is 7 times x to the 0. So for the next one we do plus 7 times 0x to the minus 1, if we're applying our rule. So that ends up being 18x, x to the power 1 is just x, minus 4, x to the 0 is 1, and then this last term will be 0. So in future ones I won't go through that. When you've got x on its own, you're just going to end up with the coefficient of x when you differentiate. And when you've got a number on its own, the 7, then that will go to 0, because the gradient of a constant, which is horizontal line, is 0. Okay. Right, what's for C? For C, we have got y is 9x to the minus 2 minus 4x to the half plus 7. So dy by dx is going to be negative 2 times 9, so negative 18x, and when we subtract 1 we get negative 3. And then we've got a half times negative 4, so that's negative 2x, and we reduce the power by 1, so minus a half, plus 7 just goes to 0. Okay, D, so this time we've got y is 1 over x cubed plus the third root of x. Right, now in this case we don't like this setup. It's great for solving problems, but it's not good for calculus differentiation. So we're going to first of all write this as x to a power. So this will be x to the minus 3, and this will be x to the power of third. And now we can apply our differentiation rule. So we bring the power down, and we reduce the power by 1. And on the next one we bring the power down, and reduce the power by 1. Okay. For E, we've got very similar. So we've got y is 5 over x squared, okay, plus 6 root x. Alright, so again, we don't like this format. We need to have x to the something. So this is 5 times x to the minus 2, and this is 6 times x to the power of half. So now we can differentiate that. Okay, so we're bringing the power down and multiplying it by 5, which gives us minus 10x, and we'll reduce the power by 1, which gives us minus 3. And on the next one, we're bringing the power down and timesing it by 6, so that gives us 3, and then we're reducing the power by 1. Okay, let's have a look at the next one. So for f, we've got y is equal to 3 over 2x squared plus root 5x. This one's quite a tricky one to write in a nice format. So this means 3 over 2 times 1 over x squared, and the next term is root 5 times root x. So I've just separated out the coefficients so I'm not getting confused about how to write my powers of x. So y is 3 over 2, and 1 over x squared is x minus 2, and then we've got root 5 times x to the half. Okay, now I can differentiate. So I bring the power down, so minus 2, and I have to times it by 3 over 2, which gives me minus 3, x, and reduce the power by 1 to the negative 3. Alright, on the next one we bring the power down and multiply it by the root 5, so that's root 5 over 2, and then we reduce the power by 1. Okay, right, for g, we've got y is brackets x squared minus 3, 2x minus 7. So we simply expand out those brackets first, because you'll learn how to differentiate products next year. So I've got 2x cubed minus 7x squared minus 6x plus 21. And now I can differentiate that. And I'm going to bring the power down and times it by 2. So I've got 6x, reduce the power, squared. And then we bring the power down for the next one. So 2 times by the negative 7, reduce the power by 1. And then finally we've got a single x term, so minus 6, and we can differentiate. The 21 gives us 0. Okay, h. We have got y is equal to the third root of x times 2x minus 7. So again, we want to expand the brackets, but I'm going to write x to the third first so that I'm less confused. Okay, we add the powers. So we've got 2x to the 4 over 3 minus 7x to the 1 over 3. And now I can differentiate. So I bring down the power, so I've got 2 times 4 thirds, so that's 8 thirds, x to the, and we reduce the power by 1. And then we've got, bring down the power, so negative 7 times 1 third, and reduce the power by 1. Okay, right, last one in this question. So we've got y is equal to 5x squared minus 7 over x cubed. Okay, so for this one, we need to first of all not have a fraction. Again, you'll learn how to deal with fractions next year, but when it's just a nice algebraic one like this, we can write this as the 1 over x cubed is the same as x to the minus 3 multiplied by 5x squared minus 7. Okay, so I'll just write that next to this here so you can see where that came from. So this is the same as having 1 over x cubed times by the numerator. Okay, and I can write 1 over x cubed as x to the minus 3. And now let's expand the brackets. So we've got 5x to the minus 1 minus 7x to the minus 3. And then we can differentiate that. Bring the power down, multiply it by the 5, reduce the power by 1. Bring the power down, multiply it by minus 7, reduce the power by 1. There we go. Right then, there's an extension question here. Let me just turn this around. For question 5, we're given that f of x is equal to 6x squared minus 1 over 2 root x. And we have to show that the derivative of this is equal to 9 root x over 2 plus 1 over 4x root x. So the first thing we're going to do is we're going to do similar to the previous one. We're going to write this out separately. So I've got 1 over 2x to the half times by 6x squared minus 1. And I can write this as a power of x. So I've got a half times by x to the minus a half times by 6x squared minus 1. Right, and now I can expand out the brackets. So I've got a half times 6, and I've got x to the minus a half times x squared. So that's going to be x to the 3 over 2 minus 1 half x to the minus a half. Finally, I can differentiate that. So I bring the power down and multiply it by the 3. So I've got 9 over 2 x and reduce the power by 1 to the half. For the next one, we bring the power down and multiply it by minus a half, so we get plus a quarter x to the, and we reduce the power by 1, negative 3 over 2. Okay, well, I know that x to the half is a square root, so I've got 9 over 2 root x, now that's looking good, plus, when I've got a negative, it means that goes on the denominator, okay, and 3 over 2 is the same as x cubed square rooted. Remember, flower power underground roots. Now, root x cubed is the same as having, I'll just cross that off. So this bit is root x cubed is equal to root x times root x times root x. And we know that these two multiply to make x. So that gives us x root x. So then this is completely equivalent to the one that we were given in the question. So that's good news.